Hi guys, let's continue with the last part of this chapter, chapter 18. So far, the straight line graph is about y and x and direct proportion yesterday. So today we are going to do another one, which is called practical graph. It's basically just the same straight line, but then we are going to use this line for the real life problem. Like I'm going to show you a few examples here, and later on you continue with the exercise. Let's see the example from this textbook. So you can see from here, it says the cost of the car is originally 20,000, 20,000 this one, right? Then the value of the car falls by 1,500 each year. That means 1 year decrease 1,500. You just have to keep minus 1,500. So they ask you write a formula to show the value, which is the car value in $1,000. In this case, it's in $1,000 as a function of the time. That means uh, by how many years the value of the car is how much. That is the question. So basically, the answer is quite simple. You just write down value, which is V. We stand for value equal to, and originally is 20,000, right? So you just have to write 20,000. In this case, because the question asks for the value in thousand, so you don't need to write 20 and 000 at the back here. You just write 20. It's understood is like 20,000. Then after that, because every year we need to minus 1,005, so you have to put minus sign and then multiply by 1.5. Why is it 1.5? Because it's 1,500. So we just ignore the 0 because too many zero. Then followed by, because this 1,500 is per year, so you multiply it with t. T in this case represent year. The t in this case is like representing year already. So this is your equation, meaning to say at first is 20,000, right? Then every year, it depends on how many years. If 1 year, that means the t become 1. So that means 20,000 need to minus 1.5 times 1 and so on. So t will be the year. Okay. So this is the answer for A. This is the formula that we are going to have. Okay, now you need to draw the graph. You can see from this graph, this vertical one is the value V, and this one is about time T. It's not Y and X. Now we change it to V value and T. So the scale, you just follow whatever the question one. Okay. So because they ask you to draw up to 10 years. In this case, they're showing up to 10 years. So you just have to make your own scale, like one box equal to 1 until 10. And then you can see from here it's 10, right? The last one is 10. Then originally the value is 20. You can see it start at 20. This is 20,000. Then you can see the graph is going down. And with the gradient 1.5, negative 1.5, because each year you reduce 1,500, which is 1.5 in this case. So if up to 10 years, that means you need to, it's like that, 20,000. Because after 10 years, that means 1.5 will multiply 10. So after that, meaning to say you are having 20,000 minus 115. So meaning to say after 10 years, the value of your car left only 5,000. Five means 5,000. So you can draw from the graph here. You ignore the one in between. This one, this value in between, you don't need to care about it because it is going to be a straight line. So you just care about when the time is 0, that means the current year. Current year is 20,000, which is this one. And after that, after 10 years, this is value of 10. The value become 5. You can see from here. You can see from here, this is 5 here. So you just have to draw this straight line, connect 20, 0, 20 here. After that, straight up to 10, 5. In the middle, you don't care about the value in the middle because it would like proportionally decrease. So this is the graph. So basically, this is how we draw the graph. You have to start with 20 because the original price is 20,000. Then after that, after 10 years, it becomes 5. Okay, so you just have to draw this straight line. And after that, C, what is a C? C asking. C is asking when will the value falls to 11,000. So after you have the graph, when the question asks for anything that information, you can just read from the graph already. Okay, if the question asking for what is the value after when will the value falls to 11,000? So you read from the graph, find out where is 11 here. This one somewhere here, huh? Somewhere here. So if you draw the graph with the bigger scale, that means you can easily identify. But this one is very hard, right? And 11,000 is so hard to read. How do you judge this is 11? So basically, if you draw this graph accurately, that means you can read the graph from here. You can see, it's roughly 6 years. Yeah, roughly 6 years from here. Okay, 11 is somewhere here. Right, this one is about 11 here, and then you draw this line until you touch the line that we have, the straight line. Then you see the value here. So you have answer of 6. That means after 6 years, the value is going to be 11. Okay, so this is how we use the straight line graph to answer some question from our real life problem. So this is called practical graph. Okay, so actually, if without this graph, you also can count it out, right? So basically, if without graph, because we know the formula, this one is our formula already. So you just have to, because the question asks for 11,000, so you meaning to say the V now change to 11, then equal to 20, still 20, then minus 1.5. The T is the value, if the one that we are looking for right now. That's how we have the year. Then we look for the value, become 5. Now I have the value. The value after certain year, it become 11,000. So I need to know what is a T. You solve from this one, like 11 minus 20 equal to minus 1.5 T. Okay, then after that, you get negative 9, right? Equal to negative 1.5 T. So from here, T is actually equivalent to negative 9 divided by negative 1.5. That's why our answer is 6. Okay, exactly 6. So this is by algebra way. This is like by algebra way. This is by graphic method. You can read from the graph. Okay, so this is how we solve this kind of problem. Okay, next, I show you another example from this exercise. Okay, question 1. Let's say question 1. A tree is 6 meters high. So originally it's 6 meters. It grows 0.5 meter per year. Every year grows 0.5. So I want you to write down to show the height, which represented by Y right now, and then with the time. Okay. So what you do is you have to draw the graph like that. X is time in this case. This is time here. Okay. And this is the height. The height the height of the tree in this case is represented by Y. Y. It says Y, the book says so. So the time will be in years. The X is in years. So you have to make your own scale. Okay. Just make your own scale. Okay. Then they ask you to write down a formula. The formula will be Y, which is the height of the tree. Originally it's 6, right? So you have to start with 6. Then because every year increase 0.5, so you need to plus instead of minus. You need to plus 0.5, which multiply by the year in X. Year is in X this time. So the formula is Y equal to 6 plus 0.5X. That is the formula. All right. With this formula, you can draw the graph. All right. You can draw the graph. Okay, if you have 6 in front, that means we are going to start at 6 now. Right? This is 0 here. Right? You can start with this is 0, then this is 6. Okay, every year increase 0.5. So if let's say I only need to draw up 10 years. So that means after 10 years, if every year increase 0.5, 10 years increase 5, right? So in the end, I have the graph is going up like that. And then when I reach 10 years, the height here is supposed to be 11, right? Because 6 plus 11. Because 6 plus 0.5 times 10 equivalent to 5, right? So you have to get this. So you have 11. That means after 10 years, your tree is going to be with the height of 11 meters. So this is the answer. So you just have to draw like that one. So this is the line that we want. Huh? So after that, the question asks you to use your graph to find the height of the tree after 5 years. So basically, if your drawing, the scale are correct, so you just have to write, get the value of 5 here, because the question asking for after 5 years, what is your the height of the tree. So if your line is accurate, you just have to read from here, the 5, the time is 5, then touch this, the line, then read the value from the y. Read the value. I don't know how much is it because my graph is not accurate. You have to draw it accurately, then only you can see what is the figure. That will be your answer for the height of the tree after 5 years. Okay? And the next question is says the number of years until the tree is 10-meter high. Okay, if the tree is 10-meter high, that means you read from the y. Okay, instead of looking for the 11, so you look at the 10, the one with 10, the value of 10 here. Then you draw a line, touch this the straight line again, and then drop down to see what is the x, which is the year, giving you the tree become 10-meter high. Okay, that is the answer. I don't know how much because my graph is not accurate. You have to draw it accurately. Then only you can see the picture. All right. So of course you can use this like question like this. You must use the graph like this. You cannot use your exercise book, the square one, because you cannot see accurately. You must use tiny box like this so that you can see the value in more accurate. So let's see. Okay, so basically this is the answer. Let's see the another question. Let's see another question. Okay. Next one, I will show you another question. So on this graph, I draw it nicely, but I don't think I can draw it because I don't have ruler here. Okay, next, let's see question 4. Let's see question 4. There are 6 cars in a car park. That means originally the car inside the car park is you have 6 of them. Every minute, in this case, every minute it says 2 cars coming in. 2 cars enters the car park. No car is leaving. So that means every 1 minute, the car park is has additional 2 cars. So you need to write down a formula to show the numbers of car, which is y in this case again. And after t minutes, so that means your equation will be start with y, which is the y equal to this is the number of cars. Y equal to, because originally you have 6, right? So you start with 6. After that, every 1 minute enter 2 cars. So you need to plus right? Plus 2 times t minutes. So t basically will be the minutes. If let's say t is 1, that means 2 times 1 you get 2. Then after that plus it you get 8 and so on. If you have after 2 minutes, that means you have 4 cars entering, so you have 10 and so on. So basically this is the answer for the formula. This is the formula that we want. Okay, so the question asks you to use this information to draw the graph again. Okay, so basically it's like that. You can put y here. Y will be the how many cars, and t will be the in minutes. T is here, how many minutes. Okay, so you start with 0, let's say. Okay, then 1, and then 2, and so on. You just have to write it out. So let's say I also then this part, right? This part you can put this is 2 car, 4 car, 6 car, 8 car, and 10 car, and so on. Right? This scale depends on what to your preference. It's not necessarily must be like that. It can be 1, 2, 3, 4, 5, and so on. Because I want to save space here, I don't have space. So I make it 2, 4, 6, 8, 10. So basically the car at 0 minutes, That's it. Currently it start with 6 because the originally the car is 6 in that car park. So every 1 minute, this is in minute, in minutes, you have 2 car entering. So after 1 minute, that means you need to have 8 law, become 8, and 2 minutes again. After 2 minutes, it become 10, and so on. So the graph is going to be like this. You just have to draw it like that. Use a ruler. Okay. Then after that, after you have this is your answer already. So this is the graph that the question asks you to draw. Right? Draw a graph to show the numbers of car in the car park. This is the answer. The whole thing here is answer. Right? So you can mention this. This is why maybe you can say numbers of car. You just write it out. Okay. So after that, once you have this graph done, then you have to use your graph to answer the question. Let's see. The question asks for the numbers of cars after 5 minutes. After 5 minutes, then 1, 2, 3, 4, 5. So 5 minutes right here. So you draw a line, a dotted line if possible. So touch this thing, touch this the straight line, then you can see what is the figure here. This is the answer. So we have 10, 12, 14, and 16. That means after 5 minutes, I have 16 cars. Okay, so that is the answer for here for the CI. CI is 16. Okay, so the question next one, it says the time before there are 24 cars in the car park. So if the question now asking for 24, my graph not enough to show you. If your graph is accurate one, so you just going up 18, 20, 22, 24, and so on. So you just go up, then you see what is the value here, and see after that, right, touch here, and then see what is the value of the t. That will be your answer. My graph cannot show because it's out of the range already. So make sure you have space for you to draw up to 24. Then you can see what is the value of the t. That means after t minutes, after this minute, the car park is going to have 24 cars altogether. All right. So basically, this is all about this practical graph. It's something like we are using the straight line graph to answer the question like from this section. So you have exercise to do later on. After I finish this, you can just continue with this exercise. All right. Thank you.